welcome to our channel Knowledge Hub. Friends, subscribe to our channel and click the bell icon for the latest update. Today we're gonna start with your physics class 11, and that is your class 28. 27th classes we had done. In that we had done many of the important topics like vector additions, analytical method, as well as the subtraction as well. So now today we're gonna start with this class, that is your unit 4, which is motion in a plane. Before starting with this, it's a huge request to all the viewers to please go ahead with like, share and subscribe so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. Other than this, unit 4 we had done unit 1, which is your physical world. Unit 2 is your units and measurement. Unit 3 is your motion in a straight line, and unit 4, which we had started, we will continue. That is your unit 4 is your motion in a plane. So let's start with the question here. The question is, find the magnitude and direction of the resultant of two vector A and B in terms of their magnitude and angle theta between them. Find the magnitude and direction of the resultant of two vector A and B in terms of their magnitude and angle theta between them. So we solve this so that it will get you into the results here. So we have a diagram here. So on the same way, this is M theta and this is R, this is beta, this is alpha, here is theta. So this is the structure here, where let OP and OQ represent the two vector A and B, and that making an angle theta. Then using the parallelogram method of vector addition, OS that represent the resultant vector R, and that will be here R equals to A plus B. So here Sn is a normal to OP and PM is normal to OS from the geometry of the figure. So it will be OS square equals to ON square plus Sn square, but ON equals to OP plus PN. So PN that is equals to A plus B cos theta. So Sn equals to B sin theta. OS square equals to A plus B cos theta square plus b sine theta square, or r square equals to a square plus b square plus 2ab cos theta, where r equals to under root square हटेगा इधर अंडर रूट आएगा, b square plus 2ab cos theta. So in triangle OSN, SN equals to OS sin alpha equals to R sin alpha, and in triangle PSN, here, that is SN equals to PS sin theta, which is equals to P sin theta. So therefore equals to R sin alpha equals to B sin theta. So R upon sin theta equals to B upon sin alpha. Similarly, PM equals to A sin alpha equals to B sin beta, or A upon sin beta B upon sin alpha. So for that, R sin theta equals to A sin beta equals to B sin alpha. We get here sin alpha equals to B upon R sin theta, where R is to be given tan alpha equals to SN upon OP plus BN equals to B sin theta upon A plus B cos theta. So here that gives the magnitude of the resultant and the equation, and its direction is known as the laws of cosines and laws of sines. Yeah. Now we talk about for another question that will deal here, which has been the another important question here. And the question is, the motor boat is racing towards north at 25 km per hour, and the water current in that region is 10 km per hour in the directions of 60 degree east of the south. Find the resultant velocity of the boat. That you have to answer it here. So we go for the same. So the question is, a motorboat is racing towards north at 25 km per hour, and the water current in that region is 10 km per hour in the direction 60 degree east of south. Find the result. Find the resultant velocity of the boat. And that we have. So the vector VB representing the velocity of the motorboat, and the vector VS VE that represent the water current, VC that represent the water current, and the direction that is specified by the problem. Using the parallelogram method of addition, the resultant R is obtained in the direction that is being shown here. So it will be -60°. This is theta. This is phi. This is VB. So here, for that we can obtain the magnitude of R using the law of cosine. Here R equals to under root VB square plus VC square plus 2VB BC cos 120°. That is equals to under root 25 square plus 10 square plus 2 into 25 into 10 half equals to 22 km per hour. To obtain the direction, we apply the law of sines. So that is R upon sine theta equals to VC upon sine phi, or sine phi equals to VC upon R sine theta 10 into sine 120 upon 21.8 equals to 10 under root 3 upon 2 into 21.8 equals to 0.397, and so phi equals to 23.4 degree. That is what we have, 23.4. So now we'll discuss motion in a plane. So motion in a plane. In this sections we shall see how to describe the motion in a two dimension using vectors, and for that position vector and displacement. So we go for it. This the position vector here are that of particle P that is located plane with reference to the origin of an XY reference frame, and that is being representing here as so that R equals to xi by j, where x and y are the components of R along x and y axis, or simply they are the coordinates of the object. So suppose a particle that moves along the curve of that thick line, and which is being delta r of r minus r dash minus here, that has been directed from P to P dash. On the same way, we can write the equation in the components, and that will be forming here. So that has been delta r equals to xi plus yj minus xi plus yj, and that is equals to I delta x plus j delta y. So delta x equals to x I bar minus x, delta y equals to y bar minus y. So where velocity, we talk about for the velocity here, in the same way. So talking about the velocity here, so in the same way. So in terms of velocity, with the average velocity of an object in the ratio of displaced and corresponding time interval, and the velocity, instantaneous velocity, is to be given in the limitations. So for the average velocity, we'll just go for it. The average velocity of an object is the ratio of the displacement and the corresponding time interval. That will be E bar equals to delta r by delta t equals to delta x I plus delta yj upon delta t equals to r delta x by delta t plus j y by delta t. So on the same way, v bar equals to vxi plus vyj. Since v bar delta r by delta t, the direction of the average velocity is the same as that of the delta r, and where the velocity, instantaneous velocity, is given by the limiting value of the average velocity as the time interval approaches to 0, and where v equals to limit delta t tends to 0, where delta r by delta t equals to dr by dt. Here the meaning of the limiting process that can be easily understood with the help of the figure that we'll draw, that the thick line of that represents the path of an object which is at p at time t, and p1, p2 and p3 that represents the positions of the object after the times delta t1, delta t2 and delta t3. On the same way, for the delta 3 and delta r1, delta r2 and delta r3 are the displacement of the object in the times delta t1, delta t2 and delta t3. Now here we go for the another one, and that what we'll be having as a graph form. So we are going to draw the graph for the velocity one, and that will be helpful for us. So here we go. X 0, this is y. So here it is. Here that what we have. So where we go for it. This is P1, P, that the arc is gone from here to here. That is from P1. So here for that, delta R1, this is R1, this is R. So on the same way, this is the direction of V. This is the direction of V here. So for that we go for another one, that has been the another graph. This is for y, x, this is 0. Here one graph, and this is the another. P2, P, r2 delta r2. This is direction of v. Now for the another graph, x, y, 0. This is delta r3, r3, r. This is direction of v. Now we have another one, x is 0, y. This is direction of v. This is p, this is r. So that is the graph that we have here, that what we'll have to discuss as well. So we have another graph as well. These were terms under the velocity. Now we go for another one, which is we talk about that delta t3 and respectively that the directions of the average velocity that is shown here, and for the three decreasing values of delta t, where delta t1, delta t2, delta t3, and is along with the tangent to the path, and therefore its direction of velocity at any point on the path of the object is tangential to the path of that point and is in the direction of motion. We can express that here in the form v equals to dx by dt, so that is equals to limit delta t tends to 0, which is delta x by delta t I plus delta y by delta t j, that we have here. On the same way, where we go for it, that is equals to I limit delta t tends to 0, delta x by delta t plus j limit tends to 0, that is delta y by delta t. Now we go for another one, which is for v equals to I delta x by t. On your same way we go for it, and that is we'll discuss the further, or v equals to I dx by dt plus j dy by dt equals to vxi cap plus vyj cap, where vx equals to dx by dt, vy equals to dy by dt here. So if the expressions for the coordinates x and y that are known as function of time, we can use these equation to find vx and vy. The magnitude of v is then your v equals to under root vx squared plus vy squared here. On the same way, and the direction of v is to be given in the form of an angle, and that is your tan theta equals to vy by vx, or theta equals to tan inverse vy by vx, and vx and vy and angle theta are shown in this for the velocity v. Now we talk about for the acceleration, that we'll discuss here. So yes, so in terms of acceleration, the average acceleration a of an object for the time interval at a moving in the xy plane, that is xy plane is the change in the velocity that is divided by the time interval. and the instantaneous acceleration also, that we did talk about it. So for acceleration, I just write it down here. The average acceleration A of an object for the time interval delta t moving in xy plane is the change in velocity divided by the time interval. That we have here. Vxi cap plus Vyj upon delta t here, which is equals to delta Vx upon delta t I cap plus delta Vy upon delta t g cap. So on the same way we go for it. Here we have a graph of the components. Vyj cap, Vxi cap. This is 0 and this is from the x here. The component Vx and the Vy of the velocity V, and that the angle theta it makes with x-axis, and note that Vx equals to V cos theta, Vy equals to V sin theta, or we can say that A bar equals to Ax I cap plus Ay j cap here. So the acceleration, which is the instantaneous acceleration of the the limiting value of the average acceleration as the time interval approaches to 0. So for that it will be a limit delta t tends to 0, delta V by delta t here. So delta V by delta t, and since delta V equals to delta Vxt I cap plus delta Vy j cap, we have A equals to I cap limit delta t tends to 0, delta Vx by delta t plus j cap limit delta t tends to 0, delta Vy by delta t. A equals to Ax I cap plus Ay j cap, where Ax equals to dvx upon dt and Ay equals to dvy upon dt. So there are the many cases, of course we will deal with the same. And here, as in this case of the velocity, we can understand the graphically the limiting process using as defining the acceleration on a graph that is showing the path of the object motion. This is shown here that to be P represent the positions of the object time t, P1, P2, P3 positions after the time delta t1, delta t2, delta t3 respectively, where in each case delta t, delta v is obtained using the triangle law of vector addition. By definition, the direction of average acceleration is the same as that of the delta v. We see that all the delta t decreases the directions of delta v that changes to the corresponding. Consequently, the direction of acceleration that changes finally the limit of delta t 0, where the average acceleration became the instantaneous acceleration and has the direction that to be shown here. where you have to note that in one direction the velocity of the acceleration of an object is always along the same straight line, either in the same direction or in the opposite direction. And however, for the motion in the 2 or 3 dimension, velocity and the acceleration will a vector that have any angle 0 to 180 degree between them here. So here we're gonna end up with. Thank you, hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion on the comment box. Thank you.